Let's get started. Vice down. Two things on the agenda for the class today. First is just reviewing the last two chapters in class, these fallacies, and then the midterm review. Again, for anyone who hasn't been paying attention, midterm is next week. Here in class, electronic, assuming I don't have a problem setting it up the way I want it on Learning Suite. And there's always this, small but measurable probability I may come with a paper test, but I don't really want to do a paper test. I don't want to have to decipher. I was a TA for the computer science department when I was undergrad. I spent a lot of time trying to decipher handwriting on short answer questions, so I'd just as soon let us all just type. And yes. Less ambiguous. Before we get started, name cards out so it doesn't get rolled. And any questions to date about anything? Joseph says he's been grading the resubmissions of various deliverables, and you all are doing really well on the resubmissions. Any brief comments on your projects? Any questions? No, everyone's just like, yeah, let's get this over with. Okay. Okay. Now to his facts, Glass adds a number of fallacies. The first one, of course, goes directly contrary to most management theory. That you can't manage what you can't measure. On the other hand, if you've been reading Peopleware like you should realize how much software development is a sociological endeavor. And indeed, a lot of what DeMarco and Lister criticize is this propensity to do management by numbers in what is essentially a very human-intensive and very personality-intensive environment. I don't know what you guys have discovered on your own just with the teams you've been in, what frictions, what accommodations, whatever. But an awful lot of software management is a soft science. This is part of what I discovered, particularly at Pages. As I've said before I got to Pages, most projects I've been on, either I was the principal developer or at most there were a couple people working. And with Pages, I suddenly had this engineering team, all of very bright, very experienced engineers, and it was a bit like the ad, I forget what tech company ran it a few years ago that showed herding cats. And I was unprepared for it. And fortunately, we had a couple of the team members who had some good skills. I learned some skills along the way. And I was digging back in my books as well. So you can't. There's stuff you can manage. That is stuff you can't measure. Now you can't manage quality, or the fallacy too is you can manage quality into a software project. And again, Glass's point here is quality has to do with the inherent attributes of the software. I can't make you write good code. I can try to punish you if you don't. I can tell you from personal experience that pain does not work well as a motivator for software engineers. I can try to inspire you to write good code. There are techniques, peer reviews, things that we've talked about before that you can do to encourage developing those qualities. And of course, ultimately, you have trade-offs that you're going to face where you're going to have to say, are we going to take this code as it is written, or are we going to spend the time and effort to try and rewrite it to meet certain quality standards? Programming can and should be egoless. Egoless programming was an idea that Jerry Weinberg proposed in the Psychology of Computer Programming back in 1971. And his concept was, programmers are too defensive about their own code. I should be able to look at my code as objectively and unbiased as any of my team members. The problem with that is one of the most, and again, if you go back to peopleware, which Glass cites to a lot, a sense of professional pride is important in software engineering. Striving for code that's elegant. There's no higher compliment as a software engineer that you can receive than to have a fellow software engineer look at your code and say, gee, I wish I'd written that. And caring about your code, and particularly if you know other people are going to look at it, is a great motivator for doing things well. Tools and techniques, one size fits all. This gets back to the classic. DeMarco and Lister talk about it. I talk about it. Glass talks about it. There is, and of course, Brooks talks about it. There is no silver bullet. I used to have this argument with Carol Teasley, who was my parallel report. She was vice president of Fannie Mae, that I worked with for 2 years. I've mentioned her before. Brilliant woman. I learned a tremendous amount from her. But she and I used to have this argument. She says there's no effective methodology because if there was, everyone would use it. And my response was, there are actually several effective methodologies, is that no one ever uses them properly. I think the truth lies somewhere in between. The problem with methodologies, and this is covered in peopleware as well, is that they tend to try and ensure the success of the development effort by turning it into a process that everyone has to conform to. That is not necessarily a bad thing. My experience, though, is that if used too heavily or in the wrong circumstances, the process becomes just as much of a roadblock as anything else. I've watched the whole rise of extreme programming, which, I frankly very much agree with the Extreme Programming Agile manifesto. I think that's a brilliant summation of a lot of the key issues in software development. And then what I see corporations trying to do large-scale software projects using Agile methodology, and they fail utterly in it. Part of your experience, part of your wisdom is going to be learning what tools, what methodologies fit best for the particular project you are on. As I mentioned before, in trouble, particularly as expert witness, there have been a number of failing IT projects I've reviewed that, and it's always after, it seems it's always after missing the second deadline. 3 weeks, slip 6 months, 3 weeks for sure should, slip 6 months. And after missing that second deadline, having slipped the second time, suddenly someone on the developer side says, I know, we'll go Agile. And that'll allow us to catch up and ship stuff. And almost always there is at most one person who has any Agile experience at all. Usually it's not that significant, but they see this as a silver bullet. And what I also see in the document records, I've seen this all after the fact, is that they try to adopt Agile, they pursue it for a few months, and then they drop it because it's not working. It's not providing any benefits. No one knows how to do it except maybe one person, and so on. Software needs more methodologies. Now, you're sort of fortunate. I lived through the golden age of methodologies when it seemed like someone was coming out with a new methodology every month. I have numerous books in my library at home about different software methodologies. it really has sort of settled down to waterfallish versus agile-ish, and some mutations between them. But for a while there, I mean, you get new, here's 5 books from Madison Wesley talking about this new methodology. Here are some templates for drawing the diagrams you're going to use. Here's this case tool that allows you to lay out the models according to methodology. And I've watched those one by one go by the wayside. They have niche uses here or there. But each, in turn, was typically sort of, well, this is the great revolution. This is going to do it. Fallacy 6, to estimate cost and schedule. First, estimate lines of code. Part of me would like to think no one ever does that anymore. Lines of code is, in some respects, one of the worst possible metrics you can do, particularly if you're doing object-oriented development where you're supposed to be doing refactoring and reducing the number of lines of code as you go along. But I am sure there are organizations out there who, when they go to estimating software projects, say, okay, we plug these numbers in, we think this is going to be 25,000 lines of code, and therefore we should need 5 programmers for 4 months, and we can get that done. Lines of code is one of the worst metrics ever. Why is it popular? It's easy. It can be automated. I mean, a good metric needs to be objective, automated, repeatable, but also needs to be informative. Lines of code meets the first 3. There's all sorts of tools to count up lines of code, and lines of code with comments, and lines of code without comments, and so on and so forth. The problem is that the information is, by and large, useless. Random test input is a good way to optimize testing. Remember my story about our CEO at Pages who said, well, can't we just get college students to pound on the keyboard for a few weeks when we're ready to ship? That was his idea of testing. Random input is almost always the worst thing. What you need to do is to understand the software and know where the boundaries are. We've talked about that before. You sort of have the state space, n-dimensional state space that the software operates in. And you know values in the center of that state space are fine, you know the values way outside the state space are bad. What you have to do is try and define where the boundaries are, what's likely going to happen. Yeah, Hunter.
Isn't it true that fuzz testing like that might still be useful? Like it won't help you make sure that you catch all of the bugs, but ensures like your code is bulletproof and can handle unexpected input?
It can be useful if it's highly automated and can run lots of random values through. In other words, if you have something that's basically the equivalent of a random noise generator, that's generating values and throwing in, you run the chance of actually triggering some potentially otherwise undiscoverable errors. But it's not a good way to optimize testing. That's the question there. It's useful like most testing things. You think back to the facts section on testing. There is no one form of testing that's the silver bullet. Testing requires a lot of human thought. Even with fuzz testing, you may want to say, okay, what are the bounds and values? There's 2 things. There's okay, some idiot user is going to type some random code in here, and I haven't properly conditioned the input to reject anything that's not within bounds. If you haven't done that, then you should go back and rewrite the code. I will not accept, a negative number in this field that's supposed to be positive integers. I will not accept the floating point value in this field. I will not accept random alphanumeric characters in this field. So part of testing is making sure the code is doing as much conditioning of inputs as possible. Within that context, then, you say, okay, I'm doing a complex chain of calculations. I've got 5 different floating point numeric values that can be put in here. Let's set up a script that's going to generate 10,000 random values for each of the fields and run that piece of code for each of those 10,000 sets and see if anything suddenly pops up as an error. And then hope that your code actually recognizes an error. We've talked about 8. Given enough eyeballs, all bugs are shallow. The problem, as we talked about last week, is that programmers tend to make the same errors. So if I've done a particular piece of code and made a particular error in it, the fact that all of you look at it doesn't necessarily mean you're going to see what the error is. If I'm less experienced than you, you may look at it. We develop mental checklists. It's like the thing I said about the classic assigns versus is equal to mistake in some programming languages. It's very easy to make. We'll have mental checklists. Okay, let's look at oh, hey, look, I recognize that because I've been making that error for 40 years. But on the other hand, for more subtle bugs, the idea that people simply looking at it will do something. The point of reviews is that someone has to explain what's going on and you have other people checking the logic in real time. That's actually a very different experience. If Hunter, if I simply hand you my code, say, are there any bugs in this? That's far less effective than if I say, Hunter, sit down with me, I'm going to explain what I wrote here and why, and what the logic is. And as I've mentioned before, my personal development efforts, that's one of my most effective debugging skills, is drag someone into my office. And as I've said, almost always I get halfway through the process and I say, oh, never mind. I just saw it. The very act of describing, that's basically a 2-person software review. And that's the point of formal software reviews. I think they're going to be doing code reviews. You want to do the same thing. Have someone explain code, and the rest of you listen to the explanation and say, oh, hey, wait, did you think about this? What about that problem? Fallacy 9. The way to predict future maintenance costs and to make product replacement decisions is to look at past cost data. That's the basic idea here is you don't know what's going to change. Systems evolve, requirements evolve, impacts evolve. A lot of systems become entrenched in organizations simply because it's cheaper to leave them running than to replace them and do the occasional patching and so on. You all have benefited, as I think I've said at least once before, from the great brush clearing of Y2K. There were hundreds of thousands of programs that were retired simply because it was easier to replace them than to make them Y2K compliant. And the discovery of just how vast that was amazing. Fannie Mae, 3,000 employees, that's where I was working. I got sucked into the Y2K thing. One of the things we discovered, Fannie Mae, an organization with just 3,000 employees at that time, had 100,000 spreadsheets in active use for tracking and analyzing data. 100,000 spreadsheets for 3,000 employees. 30 spreadsheets per employee. And they all had to be checked for Y2K compatibility, because almost all of them had gigs in them. Fallacy 10, you teach people how to program by showing them how to write programs. You start off in 142 learning how to write programs. But that's not the same as going through the process of, idea, requirements, specifications, scheduling, design, architecture, design, so on and so forth. That's the level you folks are at this point. Getting ready to jump out into the real world. So, that's it for finishing up facts and fallacies. For 2 weeks from now, don't bother reading anything till after the midterm. Like I had to tell you that. Oops. My pitfalls entries, and I'll post this slide, these slides up so you can get to there. But they're also linked to on the website. My various pitfalls entries and my white paper on patterns in IT litigation system failure. And we'll talk about that in 2 weeks. Okay. So now we come. Important thing. I'm going to stop this. I'm going to make my editing easier.